So let us now solve another problem on the basis of which covers drag force or friction force. So suppose that I have a particle and it is observed to be moving for a long time under the influence of a constant force in a medium, and there's also a drag force proportional to the square of the velocity, and we have to plot the distance versus time graph for this particle that just move into a medium where it experience a drag force which is proportional to the velocity square, which is that is drag force is proportional to the velocity and square. So the drag force is a force that will oppose the motion of the body. So suppose the body is moving in this direction, so the drag force will be in this direction. So in this question we have to evaluate or have to plot the distance versus time graph of this particle when it encounters a medium where it experiences a drag force which is proportional to the velocity square. So you can solve this problem, or if you can solve it smartly, it will be more good rather than doing long calculation and approaching the solution. What we can observe from this graph is that in the first option the velocity time graph is constant with time. So as you can see, this is an xt graph, and at every instant of time the slope of the graph is equal to theta. So dx by dt is v, velocity of the body, and v is constant at every instant of time. So when a body travel in a medium where it experiences a drag, surely its velocity will decrease with time, because the drag force will opposes the motion and the velocity of the particle will decrease. So surely this cannot be the case. So answer A is not right. So also we can see that if we have a constant velocity, then dv by dt is equal to 0. This is the acceleration of the body. So if we have a drag force on a system and the particle is moving through a medium which has a drag force or a viscous medium that depends on the velocity squared, so the motion cannot be uniform. That is, the body cannot move with constant velocity. So this is wrong. The other example, the other thing that we can see is from the graph D, which says that the distance traveled by the body decreases with the time. So at, as t is equal to 0, we have the maximum distance, but as time goes on, the distance decreases. But from our day-to-day life example, we know that x always decrease with time. For example, if you drive a car, then the distance will surely increase with time, because distance is a scalar quantity, and the distance will always increase with time. So D is also wrong. So from the C graph, we can see that at every instant of time, if I draw a slope, we see that the slope will increase with time. So that means the velocity of the particle in a medium increases with the time. So as I drop the slope of this graph, I see that at this instant slope is theta 1, and at this instant the slope is theta 2. So theta 2 is greater than theta 1. Similarly, if I draw another tangent, then this is theta 3, then theta 3 will be greater than theta 1 and theta 2, and so on. So we see that the slope of the graph, that is dx by dt, which is the v, increases with time. But if the particle is moving in a viscous medium, then velocity will decrease with time, because it experiences a drag force. So velocity will decrease with the time. So surely as time increases, the velocity will decrease. So from this graph we can see that C is also wrong. So we are just left with B. So from this graph we can see that at every instant of time the slope will decrease, and at the end of the at t tending to infinity the slope will be exactly parallel to the t axis, so the slope will be equal to 0. So this graph tells us that velocity will decrease with the time as t increases, and it also satisfies the condition that distance should increase with time, that as t increases the distance traveled by the body will increase. So this is our answer, the B. We have eliminated A because the particle is in uniform motion. At every instant of time, the velocity is constant. The we eliminated D option because distance is decreasing with the time, but it cannot be the case because in our general context or in our general day-to-day life, the distance always increases with the time. So we are just left with B and D, and we eliminated C because the slope of this graph increases with time, and slope of the xt graph is the velocity. So velocity is increasing with time, but the medium is when particle is moving through a viscous or a medium or experiences a drag, then its velocity will decrease with the time. So this is also wrong. So we are just left with B. So this is our correct answer. So let us now solve problem number 6 problem. And the problem says that we have a body of mass m that fall from rest fall from rest at a height h under the effect of gravity, and it also experiences a resistive force of minus kv square, where k is the constant of motion, v is the velocity of the particle at some instant, that is at velocity at that instant. So we have to calculate that what will be the kinetic energy of the particle when it hit the ground. So this is not spit, this is hit. So this is when it hit the ground. We have to calculate what will be the kinetic energy of the body. So when the body is falling down and at any instant the forces experienced by the particle will be mg downward and minus kv square upward, that is drag force upward. So when I write down the equation of motion, it will be m dv by dt is equal to mg minus kv square. So now we have to find the relationship between position and velocity, because our our question has given that we have a height h, and our answer also depends on the height h. So it means that we have to find the relationship between velocity and the distance. So if I now multiply the left hand side by dx and divide by dx, then my quantity will be this, and it will change to m v dv upon dx mg minus kv square. So if I now divide by m on the both side, I will get v dv upon dx is equal to g minus kv square by m. Okay, so this will be our form of the for differential equation, and I can resolve it into this. Okay, so this is square. So if I now integrate, to perform integration on the both side, I have to first evaluate the left hand side. So if I now take g minus k by m v squared to be p, then I can write k by m by v square uh, v2 dv is equal to dp. Okay, so my v dv we will change to minus dp by minus plus 2k by m. Okay, so my v dv will change to this, and if I substitute the value over here, I will get ln p. If I substitute the value of v dv and g minus km by v square equal to p, then my answer will change to ln p is equal to minus 2k by m x plus ln q. And q is some constant of integration that we have to evaluate by using the initial condition. So if I now use the initial condition that let us first write down the value of p, then we will use initial condition. So g minus k by m v square is equal to minus 2k by m x plus ln q. So if I now use the initial condition that at x is equal to 0, velocity is 0, that is at the initial point, that is at the height h when x is equal to 0, then velocity is 0. So my ln q will be ln g. If I substitute these values to this equation, so I will get ln g is equal to ln q, and my final answer will be g minus k by m v square. Sorry. So g by m minus v square upon g is equal to exponential minus 2k by m x. Okay. So this will be my value of the different. This will be my expression when I will solve the differential equation. Now I have to simplify this expression and calculate the value of velocity. So I will have minus k by m v square is equal to exponential minus 2k by m x minus 1. Okay, so minus k by m v square by g is equal to this. Now that is, if I divide by g over this side, then this will become 1, and I can take this to the left hand side and this will be minus 1, and minus k v square by g is equal to this, and my value for v square will be m g upon minus k into exponential minus 2k by m x minus 1. So if I now take the negative sign under this bracket, my value will change to v square is equal to mg by k into 1 minus exponential minus 2k by m x. That is, if I take the negative sign inside the bracket, then minus 1 will change to plus 1 and this expression will change to minus. Okay, so if I now have to calculate v square at x is equal to h, that is when it reaches the ground, that is it hits the ground, then the value of v square will be mg by k 1 minus exponential minus 2k by m h. So now I have to just multiply by half m. Now I have to just multiply this v squared at x is equal to h by half m, that is by m by 2, then my value will be m square g by k into 1 minus exponential minus 2k by h by m. That is, I have to multiply by m half m because I have to calculate the kinetic energy, and at this point we got the velocity square, so I have to multiply it by m by 2 to get the energy, get the kinetic energy at the point x is equal to 8, that is when it hits the ground. So this is how we will solve question number 6. So let us now start question number 7. In the question number 7, we are given that we have a spherical particle of mass m, and it is m in 8m, that is falling through a fluid. And if the mass m and 8m are falling through a fluid, let's say I consider a particle of mass m that is falling through a fluid downward in the downward direction, then the drag force will be applied in this direction if the motion is downward. So if the motion of the particle is downward inside the fluid, then weight will be in the downward direction and the drag force will be in the upward direction. So for this kind of motion, my differential equation will be m dv by dt is equal to mg minus fd. So if my motion of the particle is in downward direction, so this is the equation for the particle if it is moving in the downward direction through a fluid. But now we are given that what is the terminal velocity. But now we have to understand what is the terminal velocity of the particle. So let us first study what the question is asking. So the question is asking us the time tau and tau 8m. So the question is actually asking what is the ratio of the tau 8m upon and the ratio of tau m. And what is tau? Tau is basically the time taken for the particle of mass m in 8m to reach its half its terminal velocity. So tau m is the time in which the particle reach from 0 to vt by 2. So 0 is the initial velocity and vt by 2 is the half of terminal velocity. And similarly for tau 8m, tau 8m, the tau time is the time taken by particle to reach half its terminal velocity. But now we have to understand what is terminal velocity. So to understand terminal velocity, look on your right. The definition is given by terminal velocity is the maximum constant velocity that an object can take when it is falling through a fluid. So it is the maximum velocity that a particle that is falling through a fluid can take. And the special thing about this velocity is that it is constant in time. So if anything is constant in time, then the type of motion is uniform and the acceleration for this kind of motion is zero. So let us read further. Uh, it is a it arises when the net drag force balances the weight of the body. So according to the condition it says that the terminal velocity is the maximum velocity that the particle can take, and it is a constant velocity, and if it is constant in time, then the kind of motion that a fluid goes through that a particle in a fluid goes through is uniform motion since its acceleration will be zero. So terminal velocity arises when the net drag force balances the weight of the body. So generally in question it is given that the drag force is dependent on kV or the velocity of the body. So in all our question the drag force is generally dependent on velocity. So if the weight of the body balances the drag force, then the equation we will get is mg minus mg is equal to fd. And if fd is dependent on some velocity by a proportionality constant k, that is fd is proportional to v minus v by the proportionality constant k, so we can write this as minus kv. So if I balance the weight of the body and the drag force, I can calculate the velocity of the particle. Then this is equal to mg by k. So the special name for this velocity when the drag force balances the drag forces, when the weight of the body balances the drag forces, terminal velocity. So this is the definition for terminal velocity. So let us now revise again. Velocity is said to be the velocity of a body inside a fluid is said to be terminal velocity when the net force acting on the body, that is due to the fluid, that is the drag force, and the weight of the body balances out. So at that time the velocity we get is the terminal velocity, and the special property or the speciality of this velocity is that it is a constant velocity and it is the maximum constant attainable velocity by a body inside a fluid. And if it is constant in time, then the kind of motion that the body experiences is uniform. So if the motion is uniform, then the acceleration is zero. So we have to use the concept of terminal velocity in this question. So let us now solve specifically this question by taking the drag force equal to 6 pi eta rv. So let us now solve question number 7. Question number 7. Let us first solve the differential equation for a general mass m that is flowing through a fluid. So for a mass m, a particle of mass m that is flowing through a fluid, the differential equation that is satisfied the particle that is falling downward inside a fluid is m dv by dt, that is m dv by dt is equal to mg minus 6 pi eta rv. So if this is my fluid and at any instant of time, let's say at this point, I consider my particle of mass m, so the net force that is acting on the particle or the forces that are acting on the particle inside this fluid is mg in the downward direction, and fd, that is the drag force, which is given by 6 pi eta rv. And we have considered that the motion of the particle inside the fluid is in the downward direction. So if the particle is moving in a downward direction, then the differential equation of the particle is this. So let us now divide by m on the both side. So if I divide by m on the both side, the equation simplifies to this. Okay. So the form of this equation can be changed to dv by dt is equal plus 6 pi eta r v by m is equal to g. So this equation is of the form of dy by dx plus px plus q. So if I want to solve a first order differential of this kind, I have to first evaluate the integrating factor of the equation, which is given by e to the power pdx. So to calculate the integrating factor of this equation, we have to do e to the power, that is exponential to the power integration 6 pi eta r m dt. So if I integrate it by time, then this will turn out to be 6 pi eta r by m into t. So let us multiply both sides by this factor. So our equation will reduce to d by dt into v into exponential of 6 pi eta r t by m is equal to g into exponential 6 pi eta r t by m. So if I take dt that is in the denominator on the left hand side to the right hand side, then I can integrate this equation on both sides and I will get v into exponential 6 pi eta rt by m is equal to g into exponential 6 pi eta r t by m divided by m into 6 pi eta r t plus an in constant of integration c. So let us now use our initial condition, that is at t equal to 0 the velocity of the particle is 0. So at t equal to 0 this will turn out to be 0 and this will turn out to be g into 1. Okay, this in the denominator there shouldn't be any t over here. So g into 1 into m upon 6 pi eta r plus c. So the value of c will be minus mg upon 6 pi eta r. Okay, so let us now substitute the value of c in this equation. I'll get v into exponential 6 pi eta r t by m is equal to mg upon 6 pi eta r exponential 6 pi eta r t by m plus 1 or minus 1. So this will be our equation. So if I take exponential to this side, I will get v is equal to mg upon 6 pi eta r, and this will be 1 minus exponential minus 6 pi eta r t by m. Okay, so this will be our final equation. And now if I just read what is given in the question, that is the time taken by the particle to reach half of its terminal velocity is tau. So for terminal velocity, what we can do is just substitute 0 in this equation, because I told you in the concept of 7th question lecture that if I equate mg to the drag force, I can calculate the terminal velocity of the object that is falling through a fluid. So if I just satisfy this condition, I will get mg is equal to 6 pi eta r v. So v terminal of the body is equal to mg 6 pi eta r. This is the terminal velocity of the particle. So let us use this definition on this side. So v is equal to vt 1 minus exponential minus 6 pi eta r t by m. Okay, so let us now change this time to tau, because we have to calculate the time where the particle reach from 0 to Vt by 2. So let us now substitute Vt by 2 on the left side and Vt over here, and let us change our time t to tau. So this will turn out to be this, and Vt will cancel. So I'll get exponential 6 pi minus 6 pi eta r tau by m is equal to 1 by 2. Okay, so let me rub this side for more working space. So if I take log on the both side, I will get minus 6 pi eta r tau by m is equal to minus ln 2, because ln 1 is 0, then ln 1 by 2 is ln 1 plus ln 2, and ln 1 is 0, and if it is in upon, then ln a by b is equal to ln a minus ln b. So I have used this property in over here and change this to this form. So let us cancel minus minus over here. So tau is equal to ln 2 into m upon 6 pi eta r. So this is the final expression for the tau, and we see that r is proportional to m to the power 1 by 3, because density of the object will be constant. So rho is constant for both the bodies. So rho is equal to mass per unit volume, and if it is a spherical body, then it is related by r cube. So r is proportional to m to the power 1 by 3. So tau is proportional to m upon m to the power 1 by 3, which is proportional to the m to the power 2 by 3. So tau 8m is equal to 8m to the power 2 by 3 upon m to the power, that is for tau m to the power 2 by 3. So 8 to the power 2 by 3 will change to 2 to the power, sorry, I have to write 3 over here. So this will be 2 to the power 3, and I can change 8 to 2 to the power 3 upon 2 to the power 3. 3 and 3 will cancel out. So the ratio will be equal to 4. And 4 is our answer for this ratio. So 4 is the answer. So we just saw that how we can just equate drag force to the weight of the body and can calculate the terminal velocity of the object, and you can use differential equation for a body that is moving through a fluid and can calculate the special condition or satisfy special condition like the time taken by the particle to reach 0 to some Vt by 2, and can derive the relation for the time and can calculate the ratio that we require. So let us now move to another question and see how do we approach a problem.